Recording in progress.
Okay, good afternoon, everyone. Referring to the previous class, you might remember I had some technical issues. So we had a short teaching class, but I also put another link for one of our guest speakers. She changed her major from, I think it was biology to business analytics, and she's pretty successful. So I just put another video for the guest speaker that we had like a few semesters ago. For today, please go to the last week. So there is two Jupyter notebook, NLP basics, and LSA. Please download and upload them into your Databricks account and make it ready. So we'll start with NLP basics. I give you a few minutes to download and then upload into your Databricks account. Okay, so let's start from the first notebook. So for natural language processing, you know that our input is textual document, and machine learning algorithm cannot work with those textual documents. So what we need to convert them to equivalent numerics. So you might remember from business intelligence class, so I had two types of sentiment analysis or text mining. One was lexicon-based, which we call it a dictionary. The other one we use machine learning, which was sentiment classification. In sentiment classification, each column represents a word. Let's say I just made something apple. Let's say another one could be weather. So for each word in our body of documents or corpus, we have a column. So if it's in the first document, we have the word of apple, it would be 1. If we don't have, for example, weather, it would be 0. And same for the others. So let's say if our corpus, or let's say body of our body has 10,000 unique words and 100,000 maybe. I think it's too much, but anyway, if let's say you want to do text mining over Bible, so you should have so many unique words. And also, you remember I talked about feature selection. I said when you have too many variables, maybe your machine learning algorithm would not be that much efficient. You would start in local minimum, or in summary, you cannot generalize your model, and in the test set, you have low accuracy. So, because for each word, you literally could have a dummy variable of 0, 1. There is different ways of handling the issue. One is doing feature selection. So you remember I talked about feature selection, and you pick the features that has the most importance. The other ones, we end up selecting some words that are contributing more. So today, in today's session, we are looking at some approaches that instead of picking everything, we pick some columns that contributes more. Okay, so looking at the notebook that we have, as you see, first I import a Spark session and make a app name. So my app name is NLP Basics. And again, these are for managing your applications. Here we just have one node, one application. So we don't have the application management. So then I'm importing Tokenizer. So Tokenizer basically divide your document into constructing parts. Here are documents of sentences, constructing part are those words. So you can either using tokenization is the simple is a very simple function for splitting your document. Either one use more advanced one, which is Regex Tokenization. Have you ever heard of regular expressions? Okay, so so in regular expression, you have more basically options to how to split your document. For example, if you see any space or if you see a unique word, you can have that splition. So basically, at the end, you want to divide your sentence to its words. You can either using Tokenizer, just simply split everything, or have more flexibility. So you see a few examples here. So hopefully it makes more sense for you guys. So having said that, I'm importing both Tokenizer and Regex Tokenization. And I'm also using column and UDF as some of the default function for this purpose. So with create data frame, I make a data frame of 3 documents. So first column is ID number, second is the sentence. So as you see, after create data frame, I put a list of tuples. Each tuple has 2 sections, one for the ID, second for the sentence, and then I put the list of column names. With .show, you can see the data frame that I just created. It consists of the ID number and also sentences. Okay, I give you 1 or 2 minutes. If you want to add comments on your blocks, then I go to the next part, or in case you have questions. So have you ever heard of lambda functions in Python? Huh? Lambda. And no. Pardon me? Have you heard of? Okay. So do you know what does this line means? Lambda words length. So basically, lambda function is just functions, but instead of having multiple lines, you can just define a function in a shorter way. So it's not that much complex. Just another way of defining a function. Yeah. So looking at the next block, I'm using two types of tokenizer. One is just a simple tokenizer. I'm just saying that inputs under sentence column, just make an output under words, and just put all the tokens in the words column. And again, tokens just means the part of documents that I'm looking for. In the second one, I'm using Regex Tokenizer. Input is sentence, output is words. I'm just saying that whenever you see, the pattern is slash words, sorry, /words, /w, it just means don't just split everything. If you see a word, split that. And you can easily see the result later on. Also, look, I'm defining, I'm using a UDF for defining a lambda function. This lambda function just finds the length of words, and the output is integer. But let's see what happens. So tokenizer object is just an empty object of a simple tokenizer. And I'm just fitting on my data set. And I put the result into tokens. The tokens that display, I see the result. So you see, whenever it was a space, it tokenized or splitted. So even quotation mark is splitted, off is splitted, almost everything. So when I use Regex Tokenizer with the pattern that I picked, now at least in the first one, you don't see any exclamation mark. It didn't use it. It just said, I want to focus on the words. So I just exclude those things. So again, it's a regular expression, was not a part of your Python course, but in case you are interested, you can just Google it. What does each pattern mean? So now I'm using //w, but I said the default is //s plus. Just Google why you say each of them has like certain meanings, and you can see what makes them different. Then I'm going to just use the count token that I defined. It just finds the length of words column that I have. As you see, I'm just saying that from tokens, which is what my simple tokenization function, use sentence and words, and output has tokens, and also I can use the count token for that column. It just counts how many tokens are under each tokenization. So as you see, I have two outputs. First for simple tokenizer, and the second one for the fancy regular expression tokenization. For example, the first sentence has 9 tokens, the other one 8. Also, the second observation, the first one has 13 tokens, the second one is 14. So one of the interesting differences when you use single tokenizer, look at the what apostrophe s. In the simple one, it just counted as a one token. In the regular expression, it counts as two separate tokens. Okay, so far, you learned that you split your documents into its parts. We call them tokens. So the technical term or jargon is tokens. So each token later could be a column. And if those tokens exist in one document, the associated value would be 1, otherwise 0. Again, let me wait 1 or 2 minutes in case you want to add comments or questions. Then I go to the next one. Okay, so still, we are looking for some ways of getting rid of tokens that are not contributing. One way, you can use some default function that removes the stop words from each document. So intuitively, you don't expect stop words bring that much of meaning. So having said that, so we can just use a simpler stop words remover. I'm using the English one, but I've seen there are so many stop words remover in almost for most common languages, including Chinese, Hindi, Portuguese, Spanish. So in case you want to do text mining, those languages, you can easily find their packages. So as you see from Spark ML features, I'm importing stop words remover. First, I'm creating the empty object of remover underline object. I'm just saying that pick words column and return washed column. And in the washed column, you should remove all of the stop words. And then I'm applying for both simple tokenized document and also regular expression tokenized body of sentence. So the next topic is Engrams. Basically, Engrams is just fundamental for other algorithms. So Engrams, there's some, mathematical methods within that, which I won't touch it. But in case you are interested and you think you would work in the text mining, a company that heavily engaged in text mining, I strongly recommend to go further into Engrams. Basically, in the Engrams, it just means you want to select the words that work together, or usually they appear together in sentences. So n means number of those tokens, and grams you can read it as n tokens, or I mean the technical term anyway is Engrams. So let me read the definition. Engram takes a sequence of input string as the output of tokenizer. So we already tokenized some documents. The n is for specifying the number of terms for each engram. The output of transformation consists of a sequence of engrams. The engrams can be used in advanced algorithms for finding relationship between words, like which terms always appear next to each other and might be associated. So it's basically the output of this step is just finding some tokens that are associated to each other. As you see, I already applied in both of my simple tokenizer and for the regular expression ones. And like for Engram of 2, this session we review basics are next to each other. Shoot first convert textual. So maybe for just 3 or 4 sentences, it doesn't make that much of sense. But when you have a good body of documents, you can see more intuitive engrams. For example, I think first step could just, for me, is a little more intuitive. NLP lexicon, I think it's more intuitive that they should come together. Okay, so the next part is about TF-IDF, but let me just wait 1 or 2 minutes in case you have questions or want to add comments. Then I go to that part. So anyone remembers what was the purpose of TF-IDF? Pardon me? What you said?
It's like the importance of the...
Yes. So in simple tokenization, if I want to use each word as a column, I just put 0, 1. But some words might have more contributions or brings more importance or more attention. Having said that, so let me write 2 sentences. So look at these two sentences. Let's say the first one is for body of documents from Worcester Fire Department, and we are looking at Twitter. And second one, we are looking at Twitter Clark Library. Fire here could be just a common word, but here it might take a lot of attention. So if you use TF-IDF, I'm just throwing an example. Maybe here TF-IDF would be 0.5, maybe here 10. So we just give more weight to some certain words based on their importance on certain body. So this is the goal of having TF-IDF. So we don't want to have simply 0 and 1s. We just want to give more attention or importance to some specific word, or let's take token as a technical term. So let's say just instead of just saying word and some of the non-technical word, let's just be a little more technical. So anyway.
So you're saying that the frequency is more, then we give a lesser weight to it, right? And in the Worcester Fire Department, the word fire will occur many times.
Yes.
The frequency of the word will be high. So we're going to give the weightage of the word as a lower value, right?
Correct.
So in sentiment analysis, suppose like we had done some movie reviews, so in that, the important word would be like great movie or best or amazing, right? So does that also work in this case, like we use TF-IDF for that?
So maybe great or let's say bad or terrible could be somehow more common. Let's say in some of them would be a word of racial bias. It takes more attention. Or this is a racist movie. So that racist could take much more attention than this is a great movie.
Very like extreme words.
And also, I think the last class I also provided some examples and also a little about mathematics behind of that. So if you go over Moodle, the last PowerPoint, you can see the formulation. Okay, so here, on top of TF-IDF, I'm also using hashing TF. So basically, instead of doing TF-IDF or giving weights to all the words, I'm just picking the most relevant words. Having said that, here I'm just saying that instead of you just for all the words, just pick the most 20 relevance and just create, just make weight for those. You don't have to do hashing, but again, hashing is another way of focusing on the most relevant tokens. As you see, first, I'm creating inverse TF by using IDF. IDF stands for I over the, it stands for inverse. And then find TF-IDF by transform fitting over my data. Looking at the outcome, so here you can see I have 20 weights, and some of the weights are 0, 3, 12, and you might see different weights based on the importance of the words that I have. Next one, the next function that I'm using for focusing on the most relevant one is count vectorizer. In the count vectorizer, I'm just saying that whenever you want to make a vector, or I just assign the weight, instead of focusing on all words, focus on the words, some words that have some minimum frequency. For example, here, I'm just saying that when you make a vector, just focus on the words or tokens, sorry, and repeat it at least 3 times and at least in one document. So now if you look at the outcomes, so you don't see a large matrix of 0 or 1 or weights. It's just limited to some, just the words that at least repeated 3 times and at least in one document. Some that could repeat it more. So that's okay. So again, count vectorizer, it's just you make a vector. I think the name is if you look at the names, the name of count vectorizer is intuitive. You make a vector by counting your tokens, and the tokens that have at least minimum frequency in one document, or some documents over the body of your documents. I'm here for your question. Otherwise, I give you a few minutes for question or adding comments. After that, please open the LSA Jupyter Notebook. So by the way, sometimes giving you, I'm using some Python-based jargons, and I'm hearing that many of you never heard of them. These are actually very useful ones. Like I talked about pipeline, Lambda functions. These are very common skills that people might ask from you. At least Python, try to have more experience on pipeline. This is a very common skills that even they might ask in the interviews. So do you guys ever heard of PCA, Principal Component Analysis? I hear some yes and some no. No? Okay. So let me explain. So in this notebook, I want to talk about equivalent of PCA in natural language processing. So let me just draw a figure here. Okay, look at this two-dimensional figure. So if I'm, and let's say this is my, let's say A1. So this is my A1 point, A2, and A3. So what is the coordinates of A1?
1, 1.
1, 1, and Z is 0. So it is X, Y, and Z. For point A1, X is 1, Y is 1, Z is 0. What about A2? Yes. A2, 2, 1, 0. And let's say just X1, so here is 0.5. So for X1, 0.5, 2, and 0. Do I need Z, even mention about 0? Yeah, we can easily exclude it. So if I want to represent these dots or points here, I don't need Z. I can just exclude it. So just keep in mind, somehow, if you look at let's just go back to machine learning. So I said we want to get rid of some columns that are not contributing. If I just have, if I have a column of X, Y, and Z, I can just drop Z and make my machine learning algorithms much faster and much more accurate. We just want to get rid of non-contributing variables. In the more advanced one, here, I have 3 points of X1, X2, X3 on this plate. So although for each one you might have X, Y, and Z, but if you just use A and B axes on this plate, you don't have to use X, Y, Z coordinates. For example, X1 has the coordinates of A1 and B1, 2. X2, for the A, it has coordinates of 2 and 2 for B. So in PCA, you try to focus on the factors or coordinates or axes that are contributing. And in SVD of natural language processing, we also want to focus on the contributing tokens. If something like here that are not contributing the coordinates, we just want to get it. And this is 3 dimensions. So in natural language processing, you have much more than that. It's really hard to imagine. But the logic is similar to PCA, which I just showed on the board. We want to just focus on the tokens that are contributing. For example, the first one, Z, is not contributing. In the second one, instead of using X, Y, and Z, with A and B, I can just show the coordinates of my points. Okay, so this is the goal of this notebook. I put some jargons here, so in case you forget what, for example, what does a document, topic, dictionary, document means, please, you can just simply review it. Let me read the definition of latent semantic analysis. The word latent means hidden. In this context, we are referring to features that are hidden in the data. That they are hidden refers to the fact that they cannot be directly measured. These latent features are essential to the data, but are not original features of data set. So it might be some meaning or inference from your text document that are hidden, and we try to find them. Okay, so given this basic definition, do you think LSA or latent semantic analysis is a supervised learning or unsupervised? So unsupervised is something like clustering. So you don't have any dependent variable. You try to basically categorize your observation based on their similarity. I don't say they are exactly the same, they are not, but also here we are looking at some hidden semantic within your textual document, and there is no dependent variable. So LSA, or latent semantic analysis, is an unsupervised learning. So latent semantic analysis has two steps. First, we make a document term matrix, which basically you just tokenize, and each token represents a variable. And if they are in your document, the value would be 1, otherwise 0. So first we make a matrix of tokens, and then reduce the number of tokens. And we instead of similar to principal component analysis, we just want to have a smaller number of variables that represents the hidden semantic in your document. I think this is a good example. So here we have 4 documents. Each document has 1 sentence. The quick brown fox, the slow brown dog, the quick red fox, the lazy yellow fox. For example, brown is in first 2 documents, so the value is 1. And it's done in this third and fourth, the value is 0. You have dog in it might be a little typo. I think I need to fix it. So dog is not in the third one, but the value is 1. So let me just fix it later. But look at the fox. Also, it's not, okay. There's some typos here, but I think you got the point. So each row is a vector. So instead of the quick brown fox, you have this equivalent vector. Instead of slow brown dog, you have this equivalent vector. So if you look at the following block, the following block is correct. So the third sentence should be quick red dog, not fox. So sorry, there's a typo here, but I think this one is correct. Okay, I give you 1 or 2 minutes in case of questions or you want to add comments, but sorry for the typo. I fixed this table later on because some of the 0 ones has some typos. I think, where did I pick it? Yeah, this is from mine, so. The third sentence is not quick red fox, it's quick red dog.
What if we have repeated ones?
Pardon me?
Let's take we have two
Quick red fox?
If we have like the same word twice.
So here, so if you had twice, you put frequency 2. Yeah, if the last one, it was the quick red fox, the fox should have a value of 2. So given the fact, you can basically use some of the blocks that I talk in the previous notebook here. For example, you can have some another block for getting rid of stop words, or you can use a certain tokenizer. So you don't have to just use them independently. You can you work them together. So when you want to use SVD, instead of you're running SVD over some like subwords, you can already use them and have them out of your documents. Okay, let's look at the big picture. So first, we had a raw text document. It could be from different resources. We made a term matrix, which each token is a column, and for each observation or document, you put its frequency. Then we need to apply single value decomposition to basically focus on lower number of observations. Count vectorizer. So looking at here, from scikit-learn decomposition, I imported truncated SVD. And I'm just saying that make a empty object of is a truncated SVD with just 2 components. So it just means we don't care how many tokens you have. At the end, we just need to have 2 components, which is kind of wild. I'm fitting on back of the words that I just created, and here's the outcome of SVD, which I assign it to LSA. So I just instead of having several tokens with the value of 0, 1s, I just have 2 variable, and as you see, each list is just summarizing the semantic which is inside each document. Usually 2 components is not that much productive, but this is just for learning purposes. So we had a very small sentence, and instead of using several tokens, we just use 2 variables. And these 2 variables represent that document. Okay, so now here I'm just making a data frame, and each document is represented with 2 variables that I'm calling topic 1 and topic 2. So look at the first one, quick brown fox. Topic 1 is 1.6, topic 2 is 2.9. Looking at the number 2 and 3, as you see, both of the topics are pretty close and could be intuitive because both of them are talking about some characteristics of dogs. So slow brown, quick red, so might be the reason why these 2 are pretty close. Last one is lazy yellow fox. Something very hard to interpret. For example, I cannot connect number 1 and 4. But at least these 2 are more closer than 2 and 3 together. I give you 1 or 2 minutes to just have questions, or if you want to add comments, then I go to the next part. So latent semantic analysis has two outcomes. First is dictionary. So it just means how they created that two topics or decomposition vectors. The second one is encoded metrics, that you can look at the direction of each token inside that they created topics or vectors. So having said that, for Brown, you can see direction topic 1 is 0.35, topic 2 is minus 14. Doug and Fox, maybe number topic 1 could be related to encompass some animal characteristics, like topic 1 of fox and dogs are close to each other, but topic 2 are different. So sometimes you can do some interpretations, but still it's not always the case, especially when you have lower number of variables. Here I sort them. I made the data frames of topic 1, topic 2, and their absolute values. So I think second one might be more interesting, because if you sort them based on absolute value of topic 1, again, fox are pretty close to each other. Yellow and red are close, brown at the end. So it might be a little confusing right now. It's first time we are seeing such a things. But in the next session, we have two actual examples of using latent semantic analysis of two sample work, and we will see some applications. So hopefully it makes more sense. But frankly speaking, text mining also is very streamlined. So it might be, you might face such a problem if you get a job somewhere, but maybe in entry levels, the chance is lower. But if you go more advanced positions, text mining is a very streamlined, and you might face a lot of tasks of doing text mining. Again, for this class, I never go through the mathematical methodology behind of that. In case you are interested for your project, or you think these are the topics you want to dig more, please also Google it and just go more into the methodology behind of that. So, for example, how to interpret SVD topics, or what's the mathematics behind of them. Questions? So if there's no question, next week we will have a session that we do text mining with the Twitter API. So we connect to Twitter website, and basically you download some tweets and we run some text mining over Twitter data. So the Twitter data that you are going to get, these are the free portion of Twitter API. In case if you get hired in some institution like news agencies or like financial companies, usually they connect to the business account of Twitter API and they get all the tweets. But here we just get a very small portions. So still we might get good results, but just keep in mind we are not working with all of them. So having said that, I think previous class I also mentioned. So first make a Twitter account. So you go to Twitter. Let me just log out. Usually I never use my Twitter that much, so. Okay, so I think sign-in is pretty easy. You can just use Google, Apple, or write email. You put username, password, day of the birth, and just click next and accept the terms. After creating your account, just sign in. And just search for Twitter API. Twitter API is the section of Twitter that it allows you to download the people's tweets. Also, you might also need to make a Twitter API account. I'm not sure how it would be for the new users. And let me just go the order, Twitter, developer platform. Okay, after making a Twitter API account, it gives you a dashboard. You need to create a project. So let me see. Yeah, for some reason today is a little different for me. So product API version 2. Okay, so for some reason for me it doesn't show up today, but you need to make a new project. So overview. Okay. It asks me to add the app, and I'm creating a new app. So okay, so just do what I said. Create a Twitter account, also create a Twitter API account, and make a new app. I need you guys to copy your app key and token. So we use these two information for connecting to your API. So have them ready, and you shouldn't share with everyone, because with this information, you can easily connect to my API and use my API. I don't have any financial interest in it, but professionally, I shouldn't share, and I'm going to delete them. So even if you have my API information, you cannot use. So again, these two for the next week: create a Twitter account, create a Twitter API account, also create an app. So as I said, you go to the dashboard, and where was that? I think they changed a little bit, so it's a little even confusing for me, but what was that? Anyway, no worries, next time I go over that. But anyway, so you create a new API and just keep your basically token and access keys, and we work from there. These are all the APIs that I did for the last semesters, and I never worked with them anymore, but so. Okay, go to project and apps and overview, and here add the app. This is the location for this new version of Twitter API. So, but anyway, even if you make those applications, you should save those information. If you don't save it, next time when you log into API, you never see them. So you cannot use the API. So we use this API for text mining, but if you are more advanced Twitter user, you can use that API for posting even new tweets. So you don't have to log in and just use your cell phone or computer type. You can make a Python code for posting new tweets. So you can do all of them with the Twitter API, but we just do it for retrieving tweets and doing text mining over people's tweets. We want to see what they are talking about. For example, let's say if people talk about nuclear bomb explosion or some big explosion, do you think the stock market would go up or down? Very down. So if Russia suddenly get crazy and they nuke Ukraine, so you expect it affects the stock market. So, and it's how people use text mining in the finance. So many financial companies, they have business account in Twitter and other US agents, other news agencies, and they retrieve so much of tweets and news, and they run text mining algorithm to predict what is the effect on the markets. So many people are working with that actually. Then they try to make money out of it, because you either should hire so many people to read all the news and tell you information, which is sometimes almost infeasible, or you can run some advanced algorithm. They retrieve tweets and news, and they, using those information, they try to predict an outcome, which is either stock goes up and down. And based on the outcome, you can do trading. Even I might teach in next summer, but there is some other Python code that you can do automatic trading. So you have basically 3 types of codes. One code retrieve tweets, news, and other information. The second part of your code do machine learning and predict the like Bitcoin or stock market, stock values. And the last part, based on the outcome of the second, it just make auto trading. So your algorithms could make like 2,000 trades in 1 hour, because you just let it do automatically. But just keep in mind, these are very serious businesses. Don't get bankrupt by bad Python coding. So it might take several months to have such a thing ready. I think with your current Python knowledge, you should be able to do that. So you don't have to use Twitter. You can use other data resources. In the second part, you can do prediction. And the last part, you can just Google how to do auto trading and just execute some trades. Hopefully you make money. If I YouTube it, I think I found some good YouTube videos. So YouTube. Finance, Bitcoin trade app. Hopefully I found. Okay, this guy. Okay, he did in Ethereum, but so this guy, I mean, you can find much better than. So what he did, he retrieved some data, and he runs some algorithms, and based on the algorithms, he do auto trading. But whatever he explained here is very basic. I'm pretty sure if you just do exactly the same, you might get bankrupt, because his internal information is very limited. He doesn't use tweets. He doesn't use other, let's say, stock market or news information. So his input information is very limited. His algorithms is super basic. But the last part, which he do auto trading, is very good. So I love whatever he did in the last, because after having that low inputs, basic algorithm, he had a good job of doing auto trading with just Python codes. And he has all the steps, but in very basic way. And he said just 100 lines of code. I'm pretty sure if you want to make something very advanced, it should be at least 2,000 lines, not just 100. So, but I love whatever he did here. Let me share over class Telegram. I should stop sharing because some of you might see. Let me share it later. So later on, send you the link. What does this guy do? But just keep in mind, his machine learning part and his data entry part is very basic. So he doesn't use great data and great algorithms. Questions? Yes? Yes. You go, if I don't make a mistake, you go to project and apps, overview, and add app. And create a new. Oh, each time it asks me this, I think I should delete previous one. Make the development, because I already made one. It doesn't let me to create. And at the end, it asks you it gives you some access key, some code, just save them somewhere. Later on, when we want to do to retrieve tweets from twitter.com, those codes basically are your username and password that you use for connecting from Python to Twitter. Any other questions? Yeah, please do that. Otherwise, in the next class, you might be a little behind of the other people who have those identification. They can easily connect. So if there's no questions, let's do our attendance. And I stop recording.